All right, every Tuesday I release 4 problems on Twitter, Instagram, Mastodon, Blue Sky, YouTube. I just post it everywhere. These 4 problems, math problems, that are designed for you to practice solving them using tape diagrams. And so in this video, I'm going to show you the answers for how I use tape diagrams on each of these 4 problems. We always do an early elementary, an upper elementary, a middle school problem, and then a challenge. So stick around for the challenge. It's a doozy. If you want to skip around in the episode thingy thing, I'll put links so you could just skip to a specific math problem if you want. But the point is for you to try and use tape diagrams to solve these problems rather than fancy math like algebra and fancy algorithms and stuff. And the tape diagrams are designed to help you make sense of the problem, not just get the right answer. So let's get started on this. And there we go. And so let's start with that early elementary problem. So it says, Tia bakes 19 cookies. She eats 3 cookies. She gives some away. She has 8 cookies left. How many cookies did she give away? So what we're going to do is we're going to say, all right, our subject is Tia. And we're going to draw a rectangle to represent that tape diagram. And that tape diagram is representing, it doesn't really matter if it lines up or not, all of her cookies. So I'm going to say, all right, so that tape diagram represents her 19 cookies. And she eats 3 cookies. So what does that look like? Well, eating 3 cookies means we can just kind of cross off some amount and say, all right, well, she just ate 3 cookies. And then it says she gives some away. What does that look like? I don't know exactly. So let's just say she gives some away. And since we don't know that actual number, let's just kind of put a question mark there and say, all right, she gave some away. And then it says she has 8 cookies left over. All right, so right here is our 8 cookies left over. And as you can see in my model doesn't really make sense because my 3 and my 8 appear to be the same size. And that's okay, folks, because a tape diagram is really supposed to just represent conceptually what's going on in the story. It doesn't have to be perfectly proportional and accurate. It needs to help the student really just make sense of the story. With this problem, we now have all the information we need. We could say 8 plus 3 is 11. So that means this plus this equals 11. And we know the whole thing is supposed to be 19. So 19 minus 11 equals 19 minus 11 equals 8. Yeah, so the answer is 8 cookies. And again, we can see, hey, our picture doesn't actually end up making sense because this is an 8 and this is an 8 and they're supposed to be equal, but they're not the same length. That's okay. And now moving down to the upper elementary, we have Stephen and Alyssa. They have collected the same number of seashells. Alyssa gives Stephen 12 seashells. How many more seashells does Stephen now have than Alyssa? All right, so our 2 characters are Stephen and Alyssa, and we're just going to give them both a tape diagram or a tape of arbitrary length. It doesn't really matter exactly how much length. The only thing that really matters at this point is they have to be the same. Stephen and Alyssa have to be the same. Now, Alyssa gives Stephen 12 seashells. So what is that going to look like? Well, let's say this is 12 right here. There's my 12 seashells, all right? So she gives him that amount, all right, right there. So the 12 that she loses are the 12 that he gains. Now it says, how many more seashells does Stephen have? Well, this entire length is Stephen. And what's Alyssa's length? Well, Alyssa's length is right here. And then, so we can see that Alyssa, here's the 12 that sort of like she gave away, which extended Stephen's tape diagram. So how many more seashells does Stephen have? It's these 24 right here. 12 plus 12 equals 24 seashells. Whoa, that's a tricky one. That was really good. All right, and now we're going to do the middle school. Mark and Rob have $288 in total. Rob spends 50% of his money. Mark spends 3/5 of his money. Now they have the same amount of money left. How much money did Mark have at the start? So our two characters are Mark and Rob, and we don't know we don't know who has more money or not. All we know, and I'll just put Rob and Mark, and I'll say, all right, here is the tape diagram for Rob, and we'll just say that. And then we'll say, and here is the tape diagram for Mark. It doesn't say they have to be equal, so I'm just going to kind of arbitrarily say 288 is like that. Right? All together, Rob and Mark have $288. Now, I don't know who has more money. Does Rob have more money than Mark, or does Mark have more money than Rob? At this point, I'm making my diagram look like Rob has more money, but that may end up not being true. The point of the tape diagram is to just help us make sense of the story. We can always go back and redraw the tape once we start to get a sense of who has more money or not. Anyway, Rob spends 50% of his money. So what does that look like? There you go. He spends 50% of his money. Now, Mark spends 3/5 of his money. They now have the same amount. So I could see, okay, so 1, 2, 3, 4, 5. So if Mark spends 3/5 of his money, they now have the same amount. So I can see that my tape doesn't really make sense anymore because this piece right here, these two units, is supposed to be the same amount as that right there. But that's okay. I can continue finishing this because I can see that if this and this are supposed to be the same amount, that means this unit right here is equal to 2 of these units down here. So I'm just going to cut it into 2. And we're going to pretend that that piece equals to that, and this piece equals to that, which means this other half can also be broken up into 2 pieces. And so like that equals that and that equals that right there, kind of a thing. We end up seeing that 9 units is equal to the 288. We could see 1, 2, 3, 4, 5, 6, 7, 8, 9. These 9 units are equal to the $288 they had at the start. That means 1 unit, doing a little bit of division, is equal to 32. And if the question is how much money did Mark have at the start, that means 5 times 32, because Mark had 5 units. That's 150, 160. So Mark had $160 at the start. That was a good one. All right, now the challenge. Here we go. So Caroline is reading a book. On Monday, she reads some pages. On Tuesday, and then on Tuesday, she reads a quarter of the number of pages remaining. Caroline has now read 3/5 of the book. She's read 75 pages more than she still has left to read. How many pages did she read on Monday? Holy moly, there's a lot going on here. All right, so let's see. Let's draw a single tape diagram. So I'm just going to draw a single tape and say, all right, there is our tape to represent the book. All right, and I'm going to turn off the grid because I don't know if I need the grid on this one. Let's see. All right, so on Monday, she reads some pages. On Tuesday, she reads a quarter of what's left, and that equals 3/5. So, okay, so I'm going to say, all right, so let's do it in red. Okay, so on Monday, she reads a bunch of pages, and let's just say this is how much she reads right there, all right? So that's what she reads on Monday, so I'll label that Monday. And then it says on Tuesday, she reads a quarter of the pages that are left over. All right, so what I need to do is I need to cut this into 4 pieces. There's our 4 pieces. And on Tuesday, she reads a quarter of the remaining pages. So, all right, so that means this piece right here is what she reads on Tuesday. All right. Now it says Caroline has now read 3/5 of the book. Okay, so what does that mean? Well, that means, let's see, let's do it in blue. Okay, so that means this is 3/5, which means this is 2/5. And it says she has read 75 more pages than she still has left to read. All right, so that means the difference between the 3/5 and the 2/5 is 75. That means 1/5 is equal to 75. Great. What does 1/5 look like? Well, we know that 1/5 is going to look like, here's 2/5. So if I just cut it in half right here, that right here is equal to 1/5. And this right here is equal to 1/5. Now, because I needed to cut this unit right in half, I can kind of do that same thing right here and right here. So I now have these like 3 little units equals 1/5. And these 3 little units equals 1/5. And I know that because I'm told that 1/5 is 75 and this 1/5 is 75. So that means each of these little units is 25. All right, now we're cooking. We are cooking. Now it says, how many pages did she read on Monday? Well, I don't know exactly yet, but let's figure out how many pages were in the entire book. All right, so let's see. So I know another 5th is like right around there. Another 5th is right around there. And another 5th is right around there. So 75 pages is 1/5. So that means 5 times 75 equals, I don't know, 75 times 5, 25, 35, 37. So it's 375 pages is the entire book. So the entire book is 375 pages. And then it says, let's see, what does it say? How many did she read on Monday? So we need to figure out this red part. So we need to figure out this green part in order to subtract it out. But that's actually pretty easy because remember, each of these was a quarter right here, and it was cut into 2 pieces. So that means this quarter is also cut into 2 pieces. So those are 75s. So I can see this is how much is not Monday. So that's 1, 2, 3, 4, 5, 6, 7, 8. So 8 units of 25. So 8 times 25, that's easy. That's 200 pages. All right, so that means 375 take away 200 is 175 pages. So that means this red part is 175. So that Monday, she read 175 pages. Wow, that was a lot. There was a lot going on. And if you made it this far, congratulations. Make sure you subscribe so you get updates whenever I post either the answers to these tape diagram problems, but I also just post a whole bunch of math videos anyway, because I think math is just beautiful, math is fun, and we should do it recreationally. And then make sure you like this video because, help me out, help a guy out, all right? Well, so thank you, and until next time, I don't know, happy recreating in your math? I don't know, whatever.